Welcome on this Wired. Today I will show you how to debug your machine learning models with overfitting. Let's go! When you train a model in data science, it's always with the goal of using the model on new data. This ability of the model to make good prediction on new data is called generalization. It's important because if the model is not performing well on new data, it's not usable for concrete applications. Overfitting occurs when the model is over-specialized on the training set and it is not able to generalize on new data. It's like you learning by heart a lesson without the ability to use your knowledge to solve new problems. Let's see a concrete example. Let's say you collect data about two different classes, green and blue, and you want to build a model to classify whether a new data point belongs to the green or to the blue. You train the model, and this is how it separates the two classes. Now you collect new data points, and you realize that your model has overfitted the training set. Indeed, the decision boundary is over-specialized to the training data, and it's not working well on the new dataset. Looking at the data, you see that a better decision boundary would be just a straight line, separating on top the green data points and below the blue data points. Overfitting usually happens when the model is too complex for your task, or you have too few data to train the model properly. As bad as overfitting sounds, it can be an ally to debug your model. If you think about it, if your model overfits, it means that it was able to learn on the training data. Then it's a clue that your training process does not have any bug. To debug your model, the idea is to create artificially the condition for overfitting. It's simple. You take a few batch of your training data and you train your model on this small sample size. If the model overfits, it means that your training process is bug-free. If it's not overfitting, you likely have a bug somewhere in your code and you can inspect and find it before training on the whole dataset. It's difficult to debug machine learning models because there is a lot of things that can go wrong. You can have a problem in your data loading, in the model itself, in the loss you use to train the model. This technique will save you tons of time, because if your model is not able to overfit on a small batch of data, it will never work on the whole dataset. Now let's have a concrete code example with PyTorch and PyTorch Lightning and show you how you can use overfitting to find a bug in the code. We use Google Colab and install PyTorch Lightning and Torch data that we will use for this project. Then we import the libraries that we will use later. We set up some styles for the plots and we are ready to go. The first thing to do is to create a toy dataset for our example and to build a data pipe with Torch data to load it into our model later. I won't go into details here, but you can check out another of my video to learn how to use Torch data for better data loading in PyTorch. The data here is really simple. It's a sine function with some random noise. The problem is the following. Given the x coordinate, the model needs to predict what is the output of the sine function at this position. We create a PyTorch module to encapsulate how our model works. It's a simple 3-layer neural network with rectified linear unit activations. But here's the catch. Based on a parameter we pass to the class, we will make a mistake on purpose. The error will be to put a last activation to our neural network. It will break the model since rectified linear unit activations output always positive numbers, so the model won't be able to predict negative values. But the sine function we need to predict has negative values, so we have a bug here. Now we build a PyTorch Lightning module that will use our PyTorch module to make predictions, but it will make our life easier for training. Since we can use the trainer module from PyTorch Lightning to abstract the training loop of our model, we create a custom metric tracker callback to save the loss at every training step. It will be useful later to plot and analyze the overfitting of our model. Now we build a function that, given a model, will overfit it on a small batch of data and output the loss for every training steps. You can see that we use the confidence parameter from the PyTorch Lightning trainer called overfit batches. If you give it an integer, it will overfit the model on the number of batches you specified. If you give it a float between 0 and 1, it will overfit the model on the fraction of the data specified. Here we use 0.1, so it will overfit the model on 10% of the data. Then we create two instances of the model, one with the error and one without the error. Then we train them and save their losses to plot them and analyze the results. We make two plots of the loss in function of the training steps. On the left, it's the result for the overfitting for the model with the bug. On the right, it's the result for the overfitting for the model working properly. We observe that the model on the left with the bug is not able to overfit the data. The loss is not decreasing over time. Whereas the model on the right without the bug is able to overfit the data. You can see that the loss is decreasing pretty fast and going almost to 0. Now you know how to use overfitting to debug your machine learning models. Make your model overfit a small sample of your training data, and if it's not working, it's likely that you have a bug somewhere in your code.